Hi, welcome to the advanced tutorial for the Pangolin laser plugin LC4D for the 3D animation software Cinema 4D. Today I will show you some helpful features and hints how to create stunning laser graphics and animations and how to render those finally to Pangolin Beyond. In case you don't have any experience so far with Cinema 4D and the LC4D plugin, I clearly recommend you to have a first look into the beginner tutorial, which you can find by following the link below. There you will get an introduction about the installation and the most important basic features. This advanced tutorial is basically separated into 3 blocks. In the first chapter we will learn more about the detailed render settings, like for example how to create sharp edges, make lines visible or invisible, render creases and object intersections. We will manipulate polygon objects in color and visibility. We will change material settings and we will learn how to use splines to add additional features in our animation. By this very famous example object, we will optimize the laser output settings in such a way that even those more complex graphics with several detailed and sharp corners can be projected in a high quality output so that the frame will be almost flicker free and nice to watch. We will optimize the corners and edges of each individual part of this object so that the output will be nice, crisp and sharp. In addition, we will check out some possibilities on how to further improve the output quality by using some special functions, so the resulting laser frame get an even more professional look. By this third really complex example animation, we will finally optimize a fully animated scene, including rigged and detailed movements. By using individual object-related Cinema 4D tags, we will try to achieve a really natural-looking laser graphic of this human hand, and all in combination with the already known Pangolin logo. By adjusting the render parameters for each individual sub-object, you will be surprised how far the overall point count of such complex stuff can be reduced without losing too much output quality. We will also use soft line effects to create smooth line transitions, optimizing anchor points and shrink down the overall point count to the lowest rational value. As you can see, there's a lot ahead of us, so just take your coffee, make yourself comfortable, and look forward to several minutes of great LC4D and Pangolin laser tutorials. So let's start with our first example for today, and what you can see is the already introduced simple 3D object, and we'll now start to optimize the laser output and learn several basic features out of the LC4D render engine. Basically, this object is a really simple one, but looking on how it has been assembled, you will see 4 standard objects like a simple cone object, 1 blue spherical object, a tank-shaped part, and all this is colliding with a simple cube in the center. To enable the LC4D plugin, we have to load it at first, of course, and this can be found in the render settings under the Effect tab. The next important step in the beginning is to set the render resolution to 320 x 320 pixels, and this is because the laser render plugin is optimized in this resolution and thus all background calculations are showing the best performance. By opening the LC4D main settings, we can already see many possibilities for default line types, and besides the default settings, we are also able to adjust the default line color, the default filter settings for advanced optimization, the laser output settings, and finally the LC4D help file, which I clearly recommend especially for beginners, since there are also many useful hints and basic knowledge included. Coming now to the first default features, and this is the line types dialog. Here we are able to adjust between silhouette and false rendering, adding creases and adjust the trigger angle, different settings for intersection calculations, and some more really great tools. So let's adjust our object now and use those features one by one. To get a first impression about the current starting output quality of our frame, let's simply render only one single view. And by clicking on the output menu item, we are now able to adjust the frame range from, for example, current visible frame or manual frame range, where we are able to adjust only one dedicated part of the whole animation. Since we want to render only the current frame, We will choose the settings accordingly for this frame we have currently selected. The standard settings are in general producing already quite nice results, but let's dig deeper into details here. The current selected settings are silhouette and false, so that all outlines are rendered including all visible outer object edges. The creases settings means that creases are calculated only when their contour angle is of 90 degrees or less, and in addition visible intersections due to object collisions are calculated as well. To see our first result, we finally click on Render Image. Looking at the laser output, we can clearly see that in general the frame looks already quite nice. All colors are shown, no real flickering visible, and in general the shape is matching as well. But as you see, there's something wrong and something to optimize as well. This contour here is not calculated as it should be. To gain a better understanding why this happens, we have to go through step by step. To understand this issue more in detail, we have to deactivate most of the settings and only remain with silhouette. This will only show the outermost edges of all objects without any creases or folds. When you render the frame now, you can see that only the outermost contour is visible and all creases are deactivated, and in fact really only the outer lines are visible for all 4 objects without any intersection or other detailed features. In the next step, we will switch back to silhouette and folds, and you can see that now also the inner contours of the individual object are shown. Anyhow, the final result is still for sure not as it should be. We see that the outlines are shown correctly, but neither the intersections between objects nor the object inner edges, like here at the top of the tank shape, are fully rendered. So this means we have to further fine adjust our render settings. By activating the creases calculation, we can bring back some of the lines already, but still some lines are clearly missing. This effect can be explained by looking at the creases angle we have set, and the angle of 90 degrees will hinder the render engine to calculate creases with an angle of smaller than 90 degrees. This means, to make the other tank shape and edges visible, we have to reduce the creases angle. And as you can see, the inner edge is now visible. Looking at the front part of the tank shape object, you can still see that this edge is still not visible, and therefore we have to further reduce the angle, and finally at around 50 degrees you can see that this edge is also visible. Just to show what the function all polygon lines means, let's shortly give it a try. And as you can see, there are so many points and lines generated that even the laser output starts flickering extremely. And this is because the render engine is really calculating all existing polygon lines and is trying to output those in parallel, as you can see. Of course, for such more complex objects it does not really make sense, but for some simple objects this might realize sometimes really nice effects. Since our frame is still not looking perfect and we are missing some lines in our result, we have to further optimize it. Those lines where the individual objects are colliding can be shown with the so-called intersection calculation. By rendering again with the intersection function activated, we are now getting a much more realistic result with all lines shown in a very nice view. Looking now at our object, we can clearly see that so far all sharp edges, corners and intersections are shown really realistic. And by rotating our object, we can also check other views as well to ensure a really fully calculated and matching result. The next interesting function is the material change calculation. And with this function, we are able to change dedicated surface parts of each object. To do this, we are activating the selection tool in Cinema 4D and can now select some surface polygons. So simply let's select this area here. And finally, let's assign a different material to only this area. So for example, this pink colored material. I now also selected the side wall of the center cube, but this does not matter for explaining the function. And after rendering this frame, we can see that our pre-selected and recolored material areas are shown in a different color. So just let's move around our object, and here I also selected 2 more sides of the center cube, but you can see that all our selected polygons are shown in their new color we just set. So simply try out several views and directions to see this effect. So just let's set it back to our initial setting. The next feature I want to explain in detail is the edge selection feature. With this very helpful tool, we are able to flexibly select polygon lines and render those lines independent from other edges or contour lines of this object. So you are able to add dedicated lines on the object surface to be rendered in high quality. To show this, I will now create 2 separate edge selections. First selection should be the outer edge of this tank-shaped object. So simply select the whole outer shape or edge of this object by holding down the Shift key and using the marker tool. As a small hint, by the way, for some objects, especially for example spheres or cones, the selection of surface lines fully surrounding the object can be simply selected by double-clicking. This is not possible here since the contour line is interrupted by the collision with the center cube object. This selection should now be stored and set to our object oil tank. Yeah, here we see the selection now. To show the flexibility of this tool, let's create another selection in the same file by selecting again some more polygon lines, for example here in this area. So we have now created 2 selections. The first selection is this one here, and the other selection is this one. We now have 2 selections, and by using the number 1 or number 2 selection from below menu, you are able to show those lines in sharp quality inside your rendered frame. This here, for example, is this outer line we selected as number 1. The very good advantage of this edge selection tool is that you are able to show only dedicated lines based on your previous selection. So, for example, if you only want to show 1 or more pre-selected lines inside the top surface of your object, but you don't want to render all folds or creases, then simply render only the outer silhouette and in addition use the edge selection tool and add dedicated lines to your rendered image. To show this feature again, let's only render our second selected lines from before. In this case, this is our selection number 2. So we will only select our previous number 2, and if we render this now, you can see the pre-selected lines from before. And here's another short example of the edge selection tool. I already selected several lines on the object surface. Afterwards, I simply activate the function for edge selection, and in this case I have only one fixed selection. Finally, after rendering, you can see that those previously selected lines are now visible as dedicated rendered lines on the object surface. So, as you have seen, you can use this edge selection tool quite flexible in several ways. Let's assume you want to get clear lines on intersections between several objects, but based on whatever reason you don't want to use the intersection tool directly, then simply select those lines near the object intersection and let them render with the just introduced edge selection function. The next interesting function is the so-called contour line feature, and this will allow you to render additional lines equally distributed over the object surface. Let us add some additional lines into this dimmer objects, and let's say we will add 3 additional lines in here over the whole height of all objects. Or simply increase the number of contours for this example to, let's say, 5 lines, and this will end up like this now. A quite similar function is the grid feature, which will allow you to show distributed grid lines over all objects. You may also reduce the density just depending on your scanner performance or based on your needs. One quite famous effect by using the feature would be to show a spherical object like a ball or similar by simply adding a grid to the object surface. I will demonstrate it here by just deactivating all other objects except the spherical one, and as a result you will get a simple spherical object in your laser output. The last function out of the default line types tab is the Calculate Splines feature. In fact, a very interesting feature, since you are able to add whatever spline-based form into your rendered laser frame. Just to start from zero, I first render our object without any additional features, and this is what we already know. But for this tutorial I prepared already one simple spline and wrapped it onto the surface of this spherical object. You can see this thin white lines showing a smiley shape on top of the blue sphere, and by hiding all the rest of the objects you can see how this spline looks like. Just bringing back all the objects. And by activating the spline calculation now, this added spline will be additionally calculated besides all the already existing objects, and therefore you'll get a sharp and bright additional feature in your rendered laser frame. This spline calculation is one really powerful function that can be used, for example, to highlight several details or hidden features on your created objects, like detailed eyelids on faces or text written on whatever objects, and so on. So this has been the major part of the default line types tab, and we will now move forward to the default line color section. In the default line color section, we will now learn how to set the color and also recolor our 3D objects before those are rendered as laser frame. If we now have a first look onto our 3 individual objects inside our scene, we have the red cone object, this blue spherical object, and this orange colored combination of cube and oil tank object. Per default, the initial rendered line color will be the native object's material color. This means if I now change the native color of the combination object from orange to, for example, green, we will see that the laser output color is also changed now from orange to green. The next color feature will be the specular colorization. And by activating this one, the selected object will be recolored in the specular or environment color of the whole scene. In this case, it's simply a whitish appearance. And again, this feature can be applied individually to all objects in our scene one by one. For the next function, custom color, you are able to recolor the entire scene based on the new selected color. This means independent from the native object's color, the whole scene will be recolored, and in this example I just choose a purple color. The next function, texture, will allow to recolor your individual objects following the assigned surface texture of each object in your scene. So for example, I will change the surface texture of the combination object to a luminance icy white surface, and after rendering this now, you will see that the adapted object will be output in the assigned texture color. And in this case it's this icy white shining color. Another very interesting function will be the colorization by scene light objects. This means that the whole scene output color is influenced by the scene light objects and the resulting shadowing effects. So let's slightly adapt a light to our scene and adjust the spot angle so that we will see some nice shadows as well. And after rendering, you can see that the previous light settings are now directly calculated into the rendered laser frame, as well by adding very nice soft lines and fadings. So, as summary, we now learned all the details about default line type settings, including some special features for optimizing the output quality, and in addition the default line color settings to adapt the laser output color for each object. For the next much more complex chapter, that default filter settings, we will change to another pre-arranged 3D object, and in this case this is the very well-known 3D Pangolin logo. Okay, this quite complex 3D object is now on far higher complexity compared to our previous examples and will allow to show the more detailed and really powerful optimization tools for optimized laser output and significant reduction of output points in our final rendered laser graphic. This Pangolin logo consists of two sub-objects. First, the red P, consisting of numerous colored boxes, and secondly, this rectangular box in the background here. And to have the ability to use additional filter settings and improved options for rendering of such complex objects besides the standard settings, we have to enable this function first. To do this, we are clicking with the right mouse button on each individual object out of our list, and we are now selecting the LC4D Beyond tag. Inside this individual Beyond tag, you can see that there are many more options in line type settings compared to the general render settings, which we learned in the previous tutorial. This starts, for example, with splines calculation, backface calculation, two-sided materials, and much more stuff that will be shown soon in deep detail. So let's look into the other additional options we are getting with the dedicated LC4D tags. Besides the line type settings, we have the filter settings, which are also included in general settings, but here slightly enhanced. And now, very important, we have the filter list of point spacing. Those options will allow you to achieve a really dedicated optimization of the laser output points that are calculated during rendering. The really impressive feature of those dedicated LC4D tags is now that we are able to align those options to each individual 3D object inside our Cinema 4D project list. This means every single LC4D tag in our object list is fully calculated on its own and dedicated to the object which the tag is linked to. So for example, I will include another LC4D tag dedicated to this base object in our list. And now we are having the ability to customize the output quality for the P object and the base object fully separated from each other. Okay, I would like to show you another hint which allows to customize the render output in even more details. And this is the so-called selection function of Cinema 4D, which is also working with the LC4D plugin. The cool part is you are not only limited to only one LC4D tag per object, so in fact you may include several tags individually for each object. In this case, for example, we will now create several selections inside the P object and also inside this gray colored base object in the background as well. These tags can then be linked to preset selections like edges or polygons of each individual 3D object. So let's create some LC4D tags first. I will start with including one LC4D tag here for this P object. And as mentioned before, the interesting part is that it's possible to include more than only one LC4D tag per object. And each LC4D tag will then be handled individually by the render engine with its own dedicated settings and also potentially linked selections. And therefore, let's include another LC4D tag into this P object. And now we will select individual parts out of this P object so that we are able to optimize and adjust dedicated settings for each of those selections. Those selections can be created by simply using the polygon selection tool or also the edge selection tool. I will use the polygon tool for now and will simply select, for example, two parts of the P object right here at the lower area. By simply marking the lower block here with the selection tool, we can now select this whole block and then choose Set Selection. The selection is now visible inside the object list and I will directly rename it now into Selection 1. Okay, save this one. And now let's include another selection. So therefore I select this second block from the bottom part. Also save as Set Selection. And we can see the second one here as well. I will rename it also into Selection 2. And now finally, I would like to include another selection inside this gray base block. And therefore I will choose now the edge selection tool. And here also easily marking 4 outer edges of this last block. And we can also see this selection here selected as edge selection. So let's simply call it edge select 1. So we have now 3 separated selections, and for the second base object I need to include another LC4D tag so that we are able to customize its render settings individually. After having this adjusted so far, I would like to link the prepared selection to each individual LC4D tag. And therefore I have to enable the selection feature below and then simply drag and drop the selection I want to have the dedicated settings for. And from now on, every single settings here I adjust below will be dedicated only for this selection I have linked. So let's change the color of this dedicated selection, for example, to yellow. And after rendering this frame, we can see that only this particular block of the P object is recolored in yellow color. All the rest still remains based on its standard settings from before. Basically, the render engine is now calculating each of those individually included LC4D tags one by one, and as a result, you will get all your pre-adjusted settings for each of your included LC4D tags. Since we have another selection inside our P object, let's for example recolor this one again into another color, and let's choose blue. And after rendering this frame, we see that the lower one still remains in yellow, whereas only this selection is now colored in blue. All the rest of the 3D objects inside your Cinema 4D scene without dedicated LC4D tag will be calculated based on the general render settings you adjusted before. You see, the selection function in fact works quite simple and flexible. And the same workflow can be used now with the gray colored base object in the background. And here we have set the upper 4 edges before as edge selection, and this means, for example, we may now also recolor only those 4 pre-selected edges into another color. Let's choose, for example, magenta as color, and after rendering we see that the lower 2 blocks from before still remain in the previously selected color settings, and only the upper 4 edges of the second object are changed into this new magenta color. Besides all this recoloration stuff, I might also choose another function and, for example, would like to have those 4 selected edges invisible in my rendered frame. This might be really interesting, for example, in very complex frames, where it might be helpful to hide some less important lines in your graphic to reduce the overall number of points your scanners have to run. So let's skip laser output only for those 4 lines. In the laser output video, you can see that those lines are now no longer included, and we saved several points to reduce flickering in our laser graphics. Okay, so we learned several quite complex details about selections and LC4D tags already. So we learned how to use the LC4D tag and how to get individually selected optimizations. We learned how to use selections and how to link them into the LC4D tags. To have some more easier stuff now in between, we are now coming back to the function overview of the LC4D tags, and I would like to explain some more functions that are only included inside the LC4D tags and not in the general settings. One interesting feature is the so-called transparency function. For example, if I select the P object and enable the transparency checkbox, we will see after rendering that the white edge line of this base object will be shining through the P object surface, since this P is now set as transparent. And we can see the result inside the laser view as well in the preview window that this P is now transparent. The next interesting part is the show backfaces function. So if we look at this gray base object, we are currently seeing the rendered image as a standard rectangular block with all hidden lines perfectly masked out. But in case we would like to make exactly those currently hidden lines visible by whatever reason, we can enable this checkbox show backfaces. This means here in the background we will see another visible edge that is normally masked out, and now the full rectangular box is transparent. Compared to other CAD or 3D programs, we may compare this and explain with a wireframed object. The next cool feature is called material two-sided. The background of this feature is if you are having the shell of an object, or for example you would like to see also the inner walls of this object, you normally won't be able to get this visible due to wrong normal vector orientation. This means polygons are only visible and rendered from one side and not from the other side. To show this, I will remove the top surface of this gray block, and we are now able to look into the inner walls of this object. The problem now is, if we are now rendering this object and we are normally not seeing any lines from the inner surface of this object. And as you see, the inner line surfaces are not shown in the rendered image, so you can only see the outer surface, but all polygons that are shown from the wrong orientation are not visible. So, since the normal vectors of each surface polygon has its dedicated orientation, the inner parts of this block are now calculated during rendering. To change this and to allow the render engine to render those inner surfaces as well, we need to enable the function material two-sided. And after rendering, we can see that the inner part of this block is now also shown perfectly. Let's just try out another view angle. And as you see, this really works pretty well, for example, to create hollow objects like spheres, rings, or other stuff where we would like to show also the inner parts. Another helpful tool inside the dedicated LC4D tag is the advanced intersection calculation. So, compared to the standard settings where we are only able to select or deselect the intersection feature, the advanced feature allows to select the order of the objects that will be considered during the calculation. By using this feature, we are now able to support the 3D depth view of a more complex object. If I render this object, we see that the red boxes are located somehow more in front compared to the gray box in the background with some minor intersections. But by using the advanced intersection features, I'm now able to select between several options to choose which object will be calculated as sitting above the other objects. The first drawn object, the second drawn objects, the nearer objects, or the farther objects inside our scene. Currently, the default setting is first drawn object. This means the intersection line color will be the red color of this P object in the front. If I now select the option second drawn object, the intersection color will be the gray color of the box in the background, which will then get the higher priority in intersection color calculation, whereas this red P object here in the front would have the lower priority. The same concept is valid for the selection farther object and closer object, which takes the 3D viewing distance into consideration. In our case, the closer object will be the red P here. So if I render the scene now, the intersection lines will be colored in red, since the P is the closer object in our scene and therefore gets the higher priority because it's closer to you as spectator. The opposite feature is the farther object tag, which will then recolor the intersection again in gray, since based on the 3D viewing position, this gray box here in the background is farther away from you as viewer. So, based on the complexity of your scene, you may use this advanced intersection feature to optimize the coloration of detailed intersection lines in your project. Coming to the next chapter, we are now talking about the filter settings dialog. Those filter options are much more detailed by using the dedicated LC4D tags. So I included one LC4D tag above, which is now valid for all objects inside the entire Pangolin logo. In comparison to the standard settings, we are seeing that there are much more options available. The first one is the so-called gap distance, which can be used to avoid double lines that are very near together but won't be really recognizable. And the second one is a minimum length feature, which will be used to filter out very short lines that are simply creating noise in your picture which you don't want to have. Overlap distance and overlap angle will be shown in the next tutorial, where we really need complex filter functions. To show the filter function gap distance, I need to somehow manipulate the current example object. So what I need to demonstrate this is a very small distance between some objects. Therefore, I simply select this box here and move it very near to the next one. So just for example and demonstration of this function. So as you see, there's a very small gap in between. And if I render this object now, we'll see that there will be two lines visible very near to each other. And in reality, those two lines will be hardly visible on your screen. So this might be a chance to reduce points. So let's see how we may save some output points to reduce flickering of the laser graphic. To try this filter function, we simply need to increase the value of gap distance. So let's do it stepwise. And still 2 lines visible, but I clearly recommend to do this in small steps, because you don't want to filter out too many details of your graphic. And after increasing this further, we see that somehow later those initial 2 lines are now shown as one single line, but as mentioned before, this minor difference will not be recognized by the audience, but will for sure reduce the flickering of your graphics due to the point reduction. If I count the point reduction by using this simple feature, I can see that the real output points is already reduced about 30 to 40 points. It's not visible in this video, but you can simply try out on your own. The minimum length feature is another really helpful tool to reduce significantly your number of output points. And by increasing the value for this length, we are able to tell the render engine to ignore short lines that won't be shown in the laser graphic later. And by rendering the image, you can see that those white connection lines in between the red boxes of this P object are no longer being rendered. And this means, by using this feature, we are able to adjust the threshold of the rendered line length. And in case you have to accept some compromise and reduce the detail level of your graphic, this might be another idea. Just one important hint. So this feature is calculating the real-time output. So in case you zoom in to the details of your graphic, of course, as you see, those lines are visible again, since at a certain moment, the real output length of those white lines in your picture is exceeding the set threshold value, and therefore those lines are calculated in again. And this short line here at the edge of the gray box is still too short to be accepted by the actual threshold value. But after zooming in further, we see that this line length is exceeding now the set value and is visible as well now. And as you know, all values in Cinema 4D can set as keyframe. This means in that case, the filter setting might be adjusted based on your animation sequence and to the level detail you currently need at each moment of your animation. So simply adjust the point density to a higher level only when you really need those details, and reduce the point level by using these filter options whenever you can allow less details and get less flickering. Until now, we learned a lot about several filter settings and its functions. And besides all those options before, one of the most powerful filters to reduce point density in your laser graphic is the point spacing filter. This one is only available inside the LC4D dedicated tags and not visible in the standard render settings. So you have to insert the LC4D tags for each object or object group where you want to have this and to use it. This point spacing filter consists of 3 main categories. So let's start with an explanation from bottom to top. The first category is called autospace distance and beam path. This consists of interpolation density of straight visible lines, interpolation of blanked lines, interpolation of curved lines, and finally the detection factor of curved lines to adjust the detection sensitivity of what line radius is interpreted as curved line. This means the higher the interpolation distance is set here, the less points are used per line in your laser graphic. And this means in general, the less points you have per line, the less flickering you may achieve, but at the cost of graphic accuracy and rounded corners. So the quality of your graphic is higher with a reduced interpolation distance. Let me show the effect by looking onto the live laser output. So for example, if I increase the point distance for visible lines to 500 and render this frame again, we can see that the flickering of our laser graphic is already reduced. In this video maybe the flickering reduction might be somehow not easy to see, but in reality it's really obvious. And from real number of output points, the overall number is reduced from 1560 points already down to only 1320 points. So the significant effect in point reduction is clearly shown by only adjusting one single parameter. I recommend to simply play around with those parameters and watch the real laser output. So, for example, if I set the value too high, like 800 or something, you can see that those normally sharp edges of those red boxes are now starting to become really roundish, and so you have to evaluate the limit of point reduction in your project to avoid insufficient image quality of your rendered laser frame. The curved line setting is responsible for the line interpolation or point density within any curved object, for example with round corners or similar. This means the higher this value is set, the less points are used to create a curve in your graphic. The result will be a reduction of overall points, but as well as less exact curvature of your graphic. So my recommendation is that you simply find out the best balance for your graphic by trying out several settings. The curve detection value is a filter adjustment that lets you adjust the minimum curve radius that will be taken into account for the curve rendering calculation. The higher this value is set, the more even smaller curves will be calculated based on the curve render settings. Or the other way around, the lower this value is, the more small curves will be considered a simple edge. In this frame, of course, this feature cannot be really shown, since we simply don't have any real curves inside. So if I change this setting, no real effect can be seen. But exactly this will be shown in the last chapter of this tutorial. The next important filter is the so-called auto blanked points. This will adjust how many points are placed at the end of the line to create a sharp line ending. And the similar function works for round overlaps of your graphic. So let's try out the following. We'll reduce the number of blank points at the line ending. And after rendering the setting, we can see those small outliers near the corners of those red boxes, which means the scanner is already moving further without stopping long enough at the corner position. This means the line endings of your graphic are losing precision, but as always we have to find a good compromise between point density and output quality to avoid too much flickering of the laser output. So you have to play around with this feature somehow. The last available but most important filter, and the one we'll check in detail now, is the auto anchor point setting. As you can see, there are many settings available, but honestly speaking, it looks much more complex than it really is. So let's start. The accelerate-decelerate checkbox will automatically include additional points near the line ending and beginning to smoothen the scanner movement and create a more stable output. So looking onto our P object, the scanner will move along this horizontal line and change to 90 degrees at the end of this part. This means physically wise that the Galvo scanner has to perform a really harsh stop at the line ending to change the movement direction. This feature will create less points in the middle of the line and more points near the end of this line, so that the scanner is somehow forced to reduce its speed at the corner, which results in the end in a more detailed velocity and a much better output quality. Let's try out to disable this function and see the output result. The output points are significantly reduced from around 1500 points down to 1230 points. This means a clear point reduction of 270 points, and therefore clearly less flickering is visible. Anyhow, also some minor quality loss is visible as well, so especially at all those corners of this object. So, depending on the complexity of your frame, you need to decide whether insisting on corner quality or on scan frequency. Since this example is on really high complexity, I would choose the option to disable this feature. Whereas normally I would always recommend to enable it whenever acceptable to achieve better graphic details. The next filter lets you adjust how many points will be added at the beginning of a visible line and also at the end of a visible line. In general, the default value is already set to a quite balanced number. But in case I would like to sharpen the corner points of my graphic, I may change this. So I will disable the acceleration function, but increase the number of beginning and end points, and thus I can also achieve sharper edges of my graphic. The same filter concept can now also be used to improve the quality based on selected corner angles. So I will slightly increase the number of all those listed angle filters. And the bigger the angles, the less points I am adding now. But this of course depends on your own graphic. In this example, the result is now an even better corner quality. So by slightly adjusting these values, you may improve the output quality in small steps in a really selective way, depending on your needs. If you want to switch back to default values, simply right-click on each value. And as mentioned, the default values are really good basic setup. But in case you need to fine adjust your graphic, this is one powerful way to have a selected quality increase. And by the way, all values can again be triggered as a keyframe, as shown before, so simply align this based on your animation. A very interesting and new feature coming with one of the latest versions of LC4D is the softline endings feature. This gives you the possibility to directly include softline endings to your rendered graphic. To explain it, I'll disable the red P now and we can focus on the gray box. So after rendering this object, we see a normal and straight looking cuboid. So let me align everything a little bit. So we will see that all edges of this cuboid are now shown very well. But if I now enable the softline feature, the corners will slightly be darkened. And as we see in the output graphic, the upper right edges of this box are shown in a darker color. One important background of the softline feature has to be understood clearly. The smoothness of those soft lines is directly linked to the interpolation distance of our object lines. This means the more points are used to create a straight line, the more soft will those soft lines be. The less points are used for the interpolation, the more stepwise will the soft fadings react. So by increasing the points that should be taken into account for the soft lines calculation, and this adjusted for straight lines as well as for corners, for example, we see after rendering that the graphic shows a massive reduction of brightness towards the edges of this cuboid. So far okay, but if I now adjust the interpolation of the straight lines of my graphic, I will receive a very nice looking and absolutely smooth line fading of the graphic, as we can see. And by further fine adjusting the parameters, I may now play around until I get the result that fits best to my needs. So let's rotate this object a little bit around, and as you can see, this feature is calculated surrounding the whole 3D object and used for all corners in the same way. Another cool function of those soft lines is to select not a linear calculation, but choosing the logarithmic calculation. And this will enable the softening in a logarithmic scale, and thus the length of the recolored corners are somehow more smooth but shorter, also quite nice looking. Coming to the last feature of the soft lines function, I need to increase the values first to explain it easier. So in our case, the so-called minimum level brightness is set to 0, and this means the corners are totally black. But by increasing this value, you might adjust the softline end brightness to a higher value. So the corners of our object are now more visible and not fully blanked out to black. And this means depending on how long and how deep the softline fading should be, you can adjust this perfectly by using all those new softline filter functions in combination. This now shown filter function is one of the most powerful filter you may use to optimize the laser output quality in terms of point density by using the LC4D plugin for Pangolin Beyond. And in the last example of this tutorial, we will use exactly those filter functions to optimize a really complex graphic in a way that it's still possible to show it on one single scanner as a laser output. So to shortly review everything, we learned details about default line types, the default line color functions, we checked the default filter settings, we learned how to use the LC4D tags with the included dedicated filters for line types, for color settings, the filter settings in detail, and last but not least, the very important point spacings, auto blank points, auto anchor points, and the auto distance beam path. So I guess it's time for a huge coffee break and see you in the last chapter of this tutorial. Welcome back, and I hope you enjoyed your well-deserved coffee break after the first 2 sessions of this quite long tutorial. This is now the last chapter of my training lesson, and we'll now focus on this final and very complex 3D object which I prepared up front. This human hand animation, in combination with the Pangolin logo, consists of many details, and when I trigger the rendering without any further optimization or filter adjustment, you will directly see the flickering of the laser output in the right lower corner, which is a result of the high number of points. This object consists of several sub-animations, and the first part will be an animation of this human hand. Let me shortly start the animation. So all fingers will be animated and have to be optimized. Secondly, we have this already shown Pangolin logo, which will be moved during this animation as well. And during this part of the tutorial, I would like to show you how to make use of all important and helpful filters we learned about during the previous sessions and how to combine those features to achieve a nice looking laser output. The overall target will be a potentially best output result for standard laser scanning units with a, let's say, realistic scan speed of 30K points per second, so based, of course, on the official ILDA standard. And looking at the current output, the current points calculated of this frame is, without any optimization by the way, 1684 points, and it is scanned with a scanning speed of 45K pps. And this means even at this high speed, running on quite fast scanners, the output is far away from considering it as flicker-free. This means the animation is not really nice, and we should now directly start with some first optimizations. Okay, so looking at this general setting dialog, we already learned that here we'll have the first basic optimization possibilities. And under this dialog, default filter settings, I will deactivate the option prevent intersection flickering. So why not using this function? Well, basically, this is a nice feature to achieve an automatic optimization of intersections for up to medium complex objects. But since this example is on a higher complexity, we'll try to optimize the intersections on a manual and even more effective way. And by deactivating this feature and starting the rendering, in our case, we can directly save around 50 points per frame. Not too much, of course, but this might be a good starting point. The second step will be using the LC4D tags, and as I have already explained, those powerful tools can be arranged to every single object of our 3D file. So we have this rectangular box, we have secondly this red pangolin P, and last but not least, our full human hand with all those fingers. So let's include LC4D tags now to every single object. This is not always necessary, of course, but in our case, let me just show the benefits we gain by doing this. First object is this red P. Right click on Beyond LC4D tags. Second one is this rectangular box. Also include the LC4D tag. And finally, when I open this hand object, you will see a lot of subgroups. And to make it simple, I just include the LC4D tag to the overall group and use it for the overall object. Now, basically, you may even optimize every single subgroup if really needed. So as first optimization, we will focus on this gray box. And by clicking on this LC4D tag and go to line types, we can do the first optimization by a very simple one. And we just prevent laser output at all. And if I render this one, you will see the gray box is completely masked out now, simply no output. And this means we have around 200 points reduced. But of course, this is not the best way to simply cut out full objects since we want to have the overall structure of this part. So undo this one, render it again. And the better option would be to use the render option of only rendering a silhouette. Instead of silhouette and folds and creases, we deactivate this one and I just activate only silhouette. And if I render this one, you will see we're reducing not of 200 points, but in this case, we can anyhow reduce the overall points to 1610 points. So also quite significant reduction of points. Next possibility for point reduction that we can try out is simplifying the red P, which is a quite complex part with many sharp edges. And simplifying the render result by disabling this creases filter, the output points will be significantly reduced. This means some lines of those rectangular shapes on each side, on each end of those red blocks are no longer rendered. And depending on the overall complexity, you always have to consider the needed details. And in this case, the reduction of such kind of elements is of course recognizable. So it's always somehow some kind of compromise. Nevertheless, the overall number of output points when you render this is reduced to 1290 points only. And I would consider this as already near to an acceptable limit for fast scanning systems. To show you some additional ideas of optimization, I will undo this step for now and continue with other possibilities. Let's now work on the more detailed areas of this animation to reduce the overall output points but without distorting the layout too much, or to risk any weird lines we don't want to see. And one perfect example to show several features in parallel is the point reduction for the human hand. When we look into the filter settings dialog, you will find settings for several line optimizations that are matching perfectly to our example. And the rendered picture shows that there are several wrinkles and lines we may exclude from the laser output to optimize the frame rate. So, for example, let's increase the gap distance to 10, and you see already a significant reduction of points. Anyhow, there's one weird line over there that should not be here. And I will, I think, change this back to roughly 5 and a little bit less. And as you see, so there are several features to play around with, and you really need to check the result in real time, as I did now. So I will paste back to 10 and check again. And let me check whether we can improve the output by changing the overlap settings a little bit more. Anyhow, the point reduction is significant, so we can save roughly 300 to 400 points again, which is quite good. But you have to play around with the settings now, and I will change maybe the gap distance again, slightly lower, and then I can check the overlap distance and the overlap angle to find some balance here. Let me check. So after playing around with those settings, I found one good overall setting, I think, to optimize the output focused on the hand object. And I think this combination of overlap distance and overlap angle might be already very good. This means in general you need to find a compromise, of course, between excluding points that are overlapping too much and also reducing wrinkles in a way that it does not distort your output file too much. So let's continue with the P object. And here we may improve the settings for gap distance and minimum length of lines that will be rendered. And this possibility has already been shown during the first part of this tutorial, where we optimized the P object as a single part. And by increasing this minimum length value, several points are already reduced without too much compromises in output quality. And in detail, those vertical lines here are partly reduced, which is almost not visible, but the point density is clearly reduced. So showing it again here, with settings of 2, for example, both vertical lines are rendered. And if I increase again back to 10, one of those lines are removed. So overall, we can reduce again of around 50 to 80 points per frame. Another additional chance to reduce points can be found inside the point distance tab for this P object. And the point distance of straight lines is currently set at 300, and I'd increase this to 500. And after rendering, the result is quite positive, since the increased point distance cannot be realized in output quality, but the flickering of the graphic is again slightly reduced, which is our main target for now. With all those angel interpolation settings, there won't be any clear recommendation, but you simply can play around and try several settings step by step, since this strongly depends on your frame you're working with. In my case, one helpful settings will be the corner detection of the hand object, since the hand is mainly showing only round shapes without real corners. This means this value can be reduced, since I don't expect any sharp corners in this object. Only for the hand, of course. A quite new and really powerful function of the LC4D plugin is this softline endings feature. And here you are able to create the very nice softline look directly in Cinema 4D, so you don't need to do it in Beyond. And here they are just playing around with the best settings, and in general, depending on the point density, the softline fading feature will create very nice fading lines. So you need to play, of course, around a little bit until you will get the best result for you. And in my case, the minimum brightness level and this setting with the density will show the best result and looks already better, I think. Important to mention is that this feature will also slightly reduce the point density, since outfaded points are not scanned anymore. After all this optimization and point filter settings, let me deactivate all filter settings just to compare the point density with and without all settings. And counting points of the output window shows an overall points of 1680 points, which of course is normally far too much for standard scanners. So I might even deactivate more filters here, but then the output quality will even be worse. So just check the output, may flicker, and after activating everything again, we again reach an output point, a number of roughly 1200 points, which is of course still quite a high number, but considering this complex frame, it's really fair. So do it again, deactivate everything, check the output quality, and after activating it again, we can compare the output quality including all filters. So the last thing we have to do now is to render the overall animation. So let's finally do this and render the full result. To render the overall animation, just check again your settings, scroll forward and backward to ensure everything works as it should be. Then go to render settings and change from current frame to all frames, because you would like to render the full animation. And let me just arrange the windows a little bit for a better view. And finally, yes, of course, don't forget to check your camera and use the right camera settings, as I will do now. Yeah, and then the only thing you have to do, finally, start the render engine. Say yes, and it will start rendering. And after all the magic happened, this will be the final animation. Looks quite smooth, and I think the result is quite okay. So the only thing I have to do now is to say thank you very much for your attention. I hope you enjoyed this tutorial, and of course, hopefully you make use of this functionality to create even better laser animations with Pangolin Beyond. Thank you very much and take care.